Welcome to Multiplying Polynomials Part 2. If you have watched Part 1, you should already have an understanding of how to multiply monomials times polynomials and monomials times monomials. This video is going to focus on examples like we see below here, which is a polynomial times another polynomial. This is different from what we did in Part 1. And if you need a refresher for Part 1, feel free to go back and watch that video again. Now, multiplying these together is a little bit trickier than just multiplying a monomial, which would be just a single term, times a polynomial, as we saw in Part 1. Your first instinct when multiplying this is probably going to be, oh, I multiply my first numbers together to get x squared, and I multiply my second numbers together to get 6. And I would get my answer as being x squared plus 6. But this would not be correct. So I'm going to leave this on the screen. Let's get rid of that title. And let's do a little simpler explanation as to why this does not work for us. Why this is not going to give us the correct answer. And to do that, let's start with something that we do know the answer to. Let's start with 5 times 6. So 5 times 6, we should know, gives us an answer of 30. Well, what we are doing in this video, and what we'll need to do here, is to demonstrate the distributive property. So I'm going to break up 5 and 6 into two equivalents. Let's say 5 is instead 1 plus 4, and 6 is instead, let's go with 2 plus 4. Now, we can hopefully agree that 1 plus 4 equals 5, and 2 plus 4 equals 6. Meaning, whenever we multiply these together, we should equal 30. Because all we did was expand out the numbers. But, if I took the approach that I did over here, and did 1 times 2, well that's 2, and I did 4 times 4, which is 16, my answer only is 18. And 18 does not equal 30. So what's going on here? Well, it turns out that when we are multiplying binomials by binomials, or any polynomials by any polynomial, we need to use a method that is called foiling. F-O-I-L. Foil. F stands for first. O stands for outer. I stands for inner. And L stands for last. So, let me rewrite our problem over here, and let's see how this is going to work. So I had 1 plus 4 times 2 plus 4. And let's do some color coding here. First is going to be red, outer is going to be blue, inner is going to be green, and let's make last be purple. So, first, you're going to take the first numbers in each parentheses, which is a 1 and a 2. So we're going to multiply the 1 and 2 together. 1 times 2 is 2. And I did that in purple, wrong color, sorry about that. Let's try that again. 1 times 2 in red is 2, so that's our first number. The outer numbers is what's on the outside of the entire setup. So that is a 1 times the 4. So we have 1 times 4, which is 4. Then I have my inner numbers. Those are the numbers on the inside of our entire setup, which is 4 and 2. If 1 and 4 are the outside, 4 and 2 must be the inside. So I have 4 times 2, which is 8. And now, lastly, we have the last numbers in our setup, which is 4 times 4. So I have 4 times 4, which is 16. And now when I add these up, look what we get. We get 2 plus 4 plus 8 plus 16. And all of that together gets me 30, which is what we wanted. So I've shown a method for multiplying with these binomials that gets us the answer we know we should get. So we can apply that to this up here. Well, let's do that. So we have our FOIL acronyms out here to help us remember: first, outer, inner, last. So let's start with our first terms. Remember, those are the first numbers in each of the parentheses. So that'll be x times x. Now x times x is x squared. Then we have our outer numbers, and that's the first in the first parentheses and the last in the last parentheses. So that'll be x times 3, which is 3x. Next we have the inner, which is the numbers that are not the outers, 2 and x. So I have 2 times x, which is 2x. And then lastly, we have the last numbers. And the last numbers is the last in each of the parentheses. So I have 2 times 3, which gives us 6. Then all I have to do is combine all of my pieces here. I have x squared plus 3x plus 2x plus 6. Now, in some cases, we might be done at this point. But notice how I have a 3x and I have a 2x here. These are common terms. They both have the same variable. So I need to combine these, meaning the x squared is going to stay, the plus 6 at the end is going to stay, but these are going to combine together to give us 5x. And this is the final answer here. X squared plus 5x plus 6. Alright, hopefully you're thinking this isn't too terrible. I do acknowledge that it is a lot. It's a lot to keep track of, but we need to remember our FOIL. Foiling these out makes it a lot easier. And another thing we should notice is when this is all said and done, it looks as though I have a claw on top and a claw underneath. You see that here? You've got the top part of the claw right here, and then you've got the bottom claw here. And that's how I think of it, to make sure that I've done these correctly. I always, for some reason, think of a crab with its claws, because I know math makes some people crabby. Well, now crabbiness can help us solving our math. Let's try another example. Alright, in our next example here, we have 3x plus 2, and we have 4x minus 6. We're going to be multiplying these binomials together again, using our FOIL method, first, outer, inner, last. So I'm going to ask you, what are our first terms? And hopefully you're able to tell me that our first terms are 3x and 4x. So we're going to multiply these together. 3x times 4x. I have 3 times 4, which is 12. And then I have x times x, which is x squared. And there's our first piece. Now we need our outer terms. So just like before, what are the outer terms? And hopefully you're able to say that it is 3x and the negative 6. So we are going to be multiplying 3x times negative 6. And as I mentioned with the last example, here's that claw or crab claw up at the top. So we know we're doing it correctly because I have a claw here. Well, I have 3x times a negative 6. 3 times negative 6 is a negative 18. And while this has an x, this one doesn't. So the x is going to tag along. It's not going to change at all. Now I need my inner numbers, my inner terms. So what numbers are going to be our inner terms? Hopefully you will say 2 and 4x. So we can multiply those terms together. I have 2 times 4, which is 8. And I have a constant with no x times a term with an x. So this x is just going to tag along like before. Now we need our last terms. So how am I going to get this bottom claw or crab claw, just like we have one up top? Hopefully you'll say that our last terms are 2 and negative 6. So we will multiply 2 times negative 6, and we get negative 12. Now before we combine them together, notice how every term got multiplied twice. 3 multiplied by here, and then we used 3x and multiplied it over here. We used 2 and multiplied it with the 4x, which was this one's second time. And then for the second multiplication of 2, we multiplied it by negative 6, which was both of theirs second multiplication. Every term gets used twice. And now, putting it all together, we have 12x squared minus 18x plus 8x minus 12. Ooh, I made a mistake. Oh, no, I'm right. Never mind. So, minus 12. Now, just like before, I have some common terms in the middle. And very often, that's going to be the case. So we're going to have to combine those. My 12x squared stays the same. My my negative 18x and my positive 8x are going to combine to give us a negative 10x. Because negative 18 plus 8 is a negative 10. And then our negative 12 will finish off the problem. And there is our answer. Okay, how are you feeling with these? Hopefully the color coding helps it a lot. Keeping the first, outer, inner, and last terms over here help us stay organized. And we're able to put everything together. But what if we have numbers that are bigger than binomials? Well, let's take a look at one last example and see what we can do. Here we have a binomial, x plus 2, and we're multiplying it by a trinomial, 3x squared minus 2x plus 4. Now, for the past examples, we have been using FOIL, which is a great way for multiplying binomials by binomials. But unfortunately, FOIL is not going to help us as much here because the trinomial has too many terms. This is where drawing those arches that I've been using will come in to be the most successful. First thing we're going to do is multiply the first number x times the first number over here, 3x squared. X times 3x squared gives us a 3x cubed. Now I'm going to still use this x, but I'm going to multiply it by the second term over here, negative 2x. And I'll use a different color. So I've got x times negative 2x. And that gives me a negative 2x squared. Because x times x is an x squared. And then lastly, for the first piece, I'm going to take this x, and who do you think I'm going to multiply it by? Hopefully you said 4 at the end, and you would be correct. So I'm going to multiply this x times 4, which will give me 4x. What have I done? I've taken this first term, and I've multiplied it by everything here. I didn't skip any terms inside, and I have 3 pieces to my answer. Now, what do you think is going to happen with this 2? Hopefully you say we're going to take this 2 and do the exact same thing as we did with the x. This 2 is going to multiply by each term inside the trinomial. So first we'll have 2 times 3x squared. That's going to give me a 6x squared. Then we are going to have 2 times the negative 2x. And that's going to give me 2 times negative 2x, which is negative 4x. And then lastly, we are going to have 2 times 4 all the way at the end. It's sort of turning out to be some kind of rainbow now. But we have 2 times 4, which gives us 8. So, just like before, each term was multiplied twice. No, actually that's not true. Each term inside here was multiplied twice. Each term in the binomial was multiplied 3 times. And that happens. So now we have to put this all together. 3x cubed minus 2x squared plus 4x plus 6x squared minus 4x plus 8. So let's put these all together now. I've got 3x cubed minus 2x squared plus 4x. Oops, didn't change color. Plus 4x plus 6x squared minus 4x plus 8. And that's supposed to be an 8 over there, sorry. So, well, do we have any common terms? Hopefully we can see that I have a negative 2x and I have a negative 2x squared and a positive 6x squared. So these are going to get combined as long as I use the right colors. And negative 2x squared plus a positive 6x squared gives me a positive 4x squared. And before we go any further, I just realized I wrote this as 3x squared when it should be 3x cubed. So that could cause some confusion. So I've combined my x squareds. That 3x cubed is going to stay in the front because we want our highest degree to be in the front. Now I've got a 4x and a minus 4x. Now this is kind of a rare occurrence because 4x plus negative 4x is 0. So these actually cancel each other out, and they will not take part or be a part of our final answer. That doesn't always happen, but today it did. So lastly, we just have plus 8. And this is the answer to our binomial times a trinomial. 3x cubed plus 4x squared plus 8. Hopefully you found this video useful. You are now getting some practice with multiplying different sized polynomials together. And good luck.